Let's see. Rivera, are you going to be invisible? Rivera, can you hear me? Rivera's answers are not audible. So Rivera is both invisible and inaudible. Typing? Why? Okay. Byron has become...
Yes.
Yeah. Byron, before I forget, you submitted blank pages. That is not allowed. You lose 1 point per blank sheet.
Wait, this was the empty.
I just had a quick look and then I saw, because I was not getting your name in the list. Fortunately, your name has appeared now. So you exist. Actually, Arash just told me, yes, Arash just told me that it is within the rules to make cosmetic changes. Therefore, you can go and re-upload the exam by taking out all the blank pages. Byron, do you hear me?
Yes, that's what I plan to do.
Yeah, just remove the blank sheets. There is another reason it was not clear to me when you were added to the class, so you may not have seen all the announcements. You have to go back and look at all the announcements and read them. But this is the only thing that I saw right away. So I thought I would tell you. I mean, I had forgotten that it's still Tuesday. So you have the time to remove them and therefore not lose points on this. Clear? What happened, Byron? I don't know if you heard me.
Yes, it's clear.
Okay, good. Good. And all of you must participate on the Discords, because if you miss something, you will hear it from other people. So if you don't participate on Discord, it's going to be bad. Okay. Now I have to remind myself what I'm supposed to, what is on exam 1B. Yes. You don't have a Zoom link. So, just what? Can someone? Oh, okay. The angry barrel, my goodness. I see. This language of hieroglyphics to which we are reverting is completely lost on me. People send me those emoticons. I have no idea what they mean. Very few of them. Okay. So now, who can look at exam 1B? And just quickly tell me what it has. It's the differential calculus business. So, is the differential business? It should be. Okay, while we wait, I'm going to talk about functions. So this is from 161, which is pre-calculus 1.
Yes, from what I can see for contents of exam 1B, it says the notes we're supposed to look at is derivatives PDF.
Okay, good. Yeah, that's what I wanted to know. Yeah, thank you. So before we can talk about derivatives, we have to talk about functions. So far, so since I've written everything precisely, this is to give you some sort of an idea as to what this is about. So a function we shall think of in a very computer sciencey way as an input-output machine. So you feed in something and something comes out. For computer science, the basically we restrict ourselves to natural numbers or inputs of type natural number and outputs of type natural number. Natural numbers include 0. Okay, we shall not suffer from vacuophobia, which is not yet recognized as a disease, but is one. Okay, so if you feed in the input x, out comes phi of x. The classical way of denoting this is by an equation y is equal to phi of x, but we shall take the approach that the graph of phi is actually the set of all xy in R2 such that y is equal to phi of x. And we assume that x is in the set of real numbers and phi of x is also in the set of real numbers. Okay, so now, for instance, we can make this a part of our physical experience in the following manner. We can say that that we have the following kind of situation. We have a container with a piston in it. So there's gas of some sort over here, and by changing the position of the piston, we can move the piston back and forth. We can increase the pressure of the gas and change the volume. Okay, now let's assume that this is enclosed in a heat bath. That means the temperature is constant. Okay, so I can think of this as an experiment in which I have control over the pressure, which is the input, and I look at the volume, V, which is the output. Both of these are real numbers. So I could be interested in knowing how does the volume change if the pressure is changed, right? And this is connected to a spring so that I have a direct control over the pressure. So I know exactly how much pressure I am applying. So for instance, I could think that this is connected by a string to a pulley, and there's a weight attached to it, and the weight I can change at will. So, I mean, there's a pan and so on, right? So that allows me to change the pressure. So this sort of experiment was actually performed. Now, those of you who are taking heat and thermodynamics, do you know Boyle's law? What does that say?
That's about gases, the
Yes.
pressures of gases with regards to temperature.
No, with volume.
Volume.
No. PV is equal to constant. That's what was found. So if one plots pressure, which is on the horizontal axis, because we have direct control over that and the volume over here, I actually don't remember whether he held volume constant. He adjusted the volume of the pressure, but doesn't matter. This is the shape of the curve. And later on, it was found that PV is equal to constant. These are called the isotherms. That means the temperature is a constant over here. And depending on different temperatures, you would have different isotherms. These are naps of rectangular hyperbola. So in mathematics, we just say xy is equal to constant, but this is how it actually arises in practice. Okay, so now the question is, the physicists then wanted to know, if I wiggle the piston a little bit, how will the volume change? So if I change it by a very slight amount, by what amount will the volume change? This led to the idea of infinitesimal changes in pressure delta P and infinitesimal changes in volume, which are delta V. They also calculated the ratio, so which led to delta, the way I have set it up. Delta V, which is the change in the unknown divided by delta P, which is the change in the known quantity. And this in the limit becomes dV dP, which is the modern notation for a derivative, but which is better written P over ddP of V, but better still, D of V. Okay? Yeah. Okay. Okay. Thank you. So this is sort of how the thing evolved. Okay. So now why am I saying all this? Because this is the point of view that the ordinary calculus books adopt. That means you have some sort of an experiment with an input and an output. The input is the type of thing that you can change directly because you have control over it. And you want to see how the output changes. Right? Okay, so now there's no reason why there should be exactly one input and exactly one output. So suppose I have this situation. I have two inputs and I have one output. So I will call them X1, X2, and this one I will call, what shall we call it? Y. Okay, so we assume again that X1, X2, and Y are all in R. Okay, so now again a question. This is hardly the most general case. What would be the most general case? We don't want to deal with particular number. So what is a particular number in this case? No, 0 doesn't occur in this picture. I have two inputs and one output. So what are the
X1 and X2 are particular numbers.
X1 and X2 are actually unknown numbers. We do not know the value.
But
Y
they are different, right? They are different though, right?
They may be different, they may be same. We do not know. X1 and X2 are only unknown real numbers. So this is a very important thing. X1 and X2 are unknown real numbers, but they may actually be equal. Okay, so this brings us again to the question of language. English is, or any other human language, usually just has a very small finite number of pronouns. Okay, so if I say he is in the garden and he is eating a hamburger, in that case it is not clear whether the two people, the one who is in the garden and the one who is eating the hamburger, are the same. Mathematics has, by contrast, infinitely many pronouns of type number, because of which I dislike the word variable and prefer to call them pronumbers, because they are pronouns of category number. Okay, so we can, if you want to distinguish between the type of number, we can call it pro-rational, pro-natural numbers, pro-real numbers, etc. Okay, but the point is, if I write x1 plus x2 is equal to 1, I do not rule out the possibility that x1 and x2 actually are equal. Clear? So I could say he one is in the garden and he two is eating a hamburger, to be more precise. And it may be the case that he one is actually equal to he two. But if I say he is in the garden and she is eating a hamburger, in the normal classification scheme, the collection of those individuals who are denoted by he and the collection of those individuals who are denoted by she have a non-empty intersection. Okay, but what somehow people seem to forget is that this does not exhaust the collection of human beings. That means these are simply two blocks of a partition scheme. Okay, for such classifications, it is best to use partitions in which the blocks are pairwise disjoint. Okay. So again, I will repeat that it is very important to understand and is a fundamental rule of algebra that x1 and x2 denote two distinct unknowns, maybe two distinct types, maybe the same type, which I have to declare beforehand, but they may be equal in value. Okay. But on the other hand, if I write x1 and x1 in two contexts, then the two x1s must have the same value. Is this clear to everyone? These are very fundamental rules of algebra. Okay. So now what did I do? If I call this phi, just one minute. Phi. In this case, classically, this would be written as y is equal to phi of x1, x2. As in the previous case, where classically this is the case, but this is very deficient because, and therefore we choose the more exact notation, x going to phi of x from R to R. And as you have already learned, this is the name of the function. This is the name of the input of an arbitrary input. This is the name of the output at the input. This is the set of inputs. This is the set of outputs. Okay. So if we do the same thing over here, we would have to write phi is defined to be x1, x2 going to phi of x1, x2 from R cross R to R. Okay, so I come back to my question, which I asked before. In this description, what are the two particular numbers that I have uttered by name? What are the two particular numbers that I have uttered, that I've actually named? X1 is not a number, x2 is not a number. 1 and 2. I've said that there are two inputs and one output. Okay, so in other words, you are still firmly attached to particular numbers. And I must do everything to wean you from numbers. Okay, so what would be the most general case? So 2 is a particular number and that should not be a number. How do we denote normally, by convention, an unknown natural number?
N.
N. So we have to have two different unknown natural numbers representing the set of inputs, representing the cardinality of the set of inputs and the cardinality of the set of outputs. So that means I have to envisage this situation. I have inputs x1, x2, all the way up to x, I will call it P, and outputs y1, y2, all the way up to yq. Arash, can you make light? Yes. So this is the most general situation. Okay, so far I have performed 3 experiments on trying to wean you from particularities of numbers, and each of my attempts has failed. So as the class progresses, I will perform this experiment over and over, because one of the goals is to wean you from numbers. Is that clear to everyone? Okay, so now in this situation, how do I denote the function? Well, first I will write classically. Classically, one would write, actually, classically, one doesn't deal with such a complicated case. Classically, one writes it this way, but it is useful to know how it will be written. So y1 will be written as phi1 of x1 up to xn. y2 is defined to be phi2 of x1 up to xn. Yn is equal to phi n. Oh, this is all wrong. Because my p's and q's have been mixed up with the. Okay, so, oh, the first one was all right, actually. First and the second one. Y1 is defined to be phi1 of y1, sorry, not y1, x1. x1, x2 up to xp. y2 is defined to be phi2 of x1, x2 up to xp. All the way up to yq, which is defined to be phi q of x1 up to xp. Okay, so now this should immediately tell you that we are really talking about two vectors. One is the vector x1, x2 up to xp, and the other is the vector y1, y2 up to yq. This is in RQ. So the input is actually a vector in RP. The output is a vector in RQ. So, and since y1, y2, etc. are functions of all the x's, so what happened? Oh, okay. Okay, so if that is the case, then I could also say that y1 up to yq is equal to phi1 xp phi q xp. My commas and dots are not coming out as well as they should. And I should point out immediately, this should not be identified with y. Phi is not a real number. Phi1 is of what type? Phi1 is a function and y1 is a number. So a number can't be equal to a function. It would be equally senseless to say in this equation that, where is the first one? Y is equal to phi. That's wrong. Y is not equal to phi. There are two different types. And since many of you have made very bad mistakes in type matching, I have to point this out. Okay? So a function and a number are two different things. So first of all, let me write down. So we write this as phi, which is defined to be phi1 up to phi q, is the function that sends x1 to xp to phi of x1 to xp from rp to rq. Okay, and you should also note that phi of x1 to xp is equal to phi1 of x1 to xp phi 2 of x1 to xp all the way up to phi q of x1 to xp. Okay. Clear to everyone? So now this is basically, this is what is called a function of several variables. Okay. So note that this makes sense because this is a number on both, it's a number on both sides. Oh. This is a number and this is a list of numbers. Yeah. Phi of x1, x2, xp is precisely this actually. It's a list of numbers. Sorry, I should say that phi of x1, xp is a list of numbers. On both sides, we have a list of numbers of length q. Okay. So in the first example, here, I didn't write down the type of, where did it go? Yes, phi is of type functions from R to R, right? So this is f and c, R comma R. But we could also write it as maps from R to R. So we can also use the notation MPS from R to R. I don't remember if I have used it in the notes MPS, but functions and maps, these are the two words that we should use. Okay. Maps are probably better than functions. Okay. So now, so that means we know that x1 up to xp, these are of type R. y1 up to yq, these are of type R. Now, phi1 up to phi q, these are functions from Rp to R. They take P inputs and give you one output. No. These are particular, these are the components of phi. Each phi1, phi2, etc. Phi1, phi2 each take, okay, so so let me write this down. So phi, on the other hand, is a function from Rp to Rq. So look at what is happening. This is phi1. Phi1 takes P inputs and gives you one output, no? Phi1. Yeah. Phi2 takes, oh, sorry, I didn't write phi. This is wrong. Yeah. Y2. Okay. Phi Q takes P inputs and gives you one output. So far, so good? Okay. So phi, on the other hand, takes P inputs and gives you Q outputs. Yeah. Clear? So now the physicist question has changed. He wants to say, I want to sort of slightly change input number 75. And I want to know how input number 557 is changing. Okay? So if I change the kth input and I want to know the change in the Lth output, how do I measure that? Now, but this is exactly the same as what is before. Experimentally, it is absolutely the same. You would talk about delta Y L delta X K, and you would compute the ratio delta YK divided by delta XK. And then you sort of delta YL, yes. Y, L. And then comes the mathematician and say that really you should look at this in the limit, or this I wrote P. L x k, and better still d dx k of YL, even better dk of YL. Okay, so the kth derivative of the else output. Clear to everyone? Now, of course, it will be far more complicated because in the case of the physicists, the unknowns are absolutely clear. But if I have some sort of a strange shape in 75 dimensions, space does not come equipped with the axes. Not to mention the fact that there's no reason to choose Cartesian coordinates. So if for the problem at hand, some other kind of coordinate is more useful, then we have to, then the nature of these unknowns with which I describe changes. Do you understand what I'm saying? I mean, in Philadelphia, we have a grid. In Washington, DC, we have a grid plus a sort of wheel and spoke arrangement, superimposed on the. Right? There are many different ways of putting coordinates on the plane. And so there are two things. I must always describe what I'm trying to describe in a manner independent of the choice of coordinates. Otherwise, it will be very hard to determine what occurred because of a choice of coordinates and what occurred because of intrinsic reasons. Okay? So you see, I can talk about Arash's height. How tall are you? 472? 172 centimeters. Okay, 172 centimeters. We'll take the proper thing. And now, but today I don't feel like measuring from the floor. I've been affected by Facebook. So I will start measuring Arash's height from the ceiling. Okay. Will any information be lost? No. So how tall is this? 2.5 meters? Yeah, about 2.5 meters, yes. Let's assume. Okay. 2.5 meters is 250. So today Arash's height from now on will be 250 minus 172, which is 28 plus 50, which is, no, 28 plus 50, that's correct. 28 plus 50 is 78 centimeters. Okay. Now, everything we just chose a different coordinates, that's all. The information is the same, but note the following. So the height is not an intrinsic feature, but now the height is not an intrinsic feature because but the distance between Arash's head and Arash's feet is an intrinsic feature. In the previous case, it would be 172 minus 0, right? In this case, it would be, from there it is 78, right? And this whole thing is 250. So it will be 250 minus 78, which is actually 172. Do you understand the difference now? So this is very, very important to understand. It is, I mean, in linear algebra, I used to sort of act it out on the floor. Oh, they removed the ruler, the huge ruler. Can you see it anywhere? No, they removed the ruler. Okay. Is this point clear to everyone who is present virtually? Or have they fallen asleep?
Yes.
Okay, good.
I'm still
Yes.
here.
Riviera has not fallen asleep. Byron, I saw a fleeting image of Byron. What happened to the rest of them? They are not visible to me.
I was making popcorn for the great lecture.
I'm on a computer and my phone, so I am visible and not visible depending on which one you're looking at.
I see, but what happened to the other people who were there? Where's Caesar? Caesar has gone off the screen. No, where?
I think I'm here.
Oh, you exist. Okay.
Yeah, absolutely.
Are you unique? That's the only question. Well, that's what, these are very fundamental questions of mathematics and differential equations. Is the solution, does the solution exist? And if it exists, is it unique?
A set of people with this DNA.
Except for the fact that in the case of Caesar, his label is usually Kate Sanchez, which changes sometime during the lecture, because he uses his wife's phone. So it's a very tricky question of logic. Also, are we saying that the image is unique, or is the object of which the image is being presented unique? Okay, well, we will accept that and proceed with this. But the question is tricky because all we are seeing is some sort of a projection using pixels on a two-dimensional surface. And it would be completely wrong to conclude that Caesar Sanchez is a two-dimensional object. But we can see, it's absolutely clear. There's no doubt that the surface of this tablet is two-dimensional. In other words, we are being fooled into believing that there is depth. I mean, the fact that we can actually go in three independent directions, does it follow logically from that? I mean, does it imply that space is three-dimensional, or that we are just have direct access to three dimensions? So in the same way, in other words, in order to relate the image that we observe, that we perceive, to the actual thing, we are making several assumptions. I mean, for all we know, Caesar Sanchez has died and someone made a video of him, and this is completely made up. Yes. So these are very difficult questions to which I don't know the answers. No, it's not conspiracy. Just yesterday I was watching a film, but just the professor said that this is showed the class, she played a trick on the students. She saw one student far away and she ran into the class and said, well, some of you are always late. I don't know what to do. Well, I will perform this experiment to prove that human beings are very weak. So she said, I'm holding up this folder, which is green. What is this color? So everyone said green. So I said, okay, if someone comes in late, I will ask the same question, but all of you say that it is red. Okay. So this poor guy comes in. Then she asked the question, what is the color of this folder? And everyone said red. And then she asked him. So he looked at her and said, it is red. So he said, you see, I just proved. And then she said that the people in Germany, despite their intelligence, all believed the Nazi propaganda. And to put it in context, there is a war raging where he's from. And there is propaganda from both sides. It is an extremely difficult task to find out what in fact is true. So one of the worst features of current times, it seems to me, that people have, some large section of human beings have decided that there's no such thing as truth. This is beyond idiocy in my view. And this is elevated to the level of philosophy and called post-truth. And it's just, I mean, words fail me if I wish to express the degree of harm that such things can do. No, it's perfectly fine. All of you have been bombarded with calculus. Incidentally, the word calculus means a stone in Greek. If you were really bombarded with calculi, it would not be very good. Yeah, but, no. There's too much deliberately false information. That's the problem. No, you have to have. It's very hard to. It's very hard. It's very hard to extract truth because descriptions are motivated. Some people whom I cannot stand would like to say that there is therefore no such thing as truth. So, and then since in that case you should be strongly empirical and take them to the roof of CCP and say, well, jump and see. If there's no truth, I claim that he will fall down and die. So if that is a false statement, there's no truth, just jump and let's see. That will shut them up, usually. So I have no tolerance whatsoever for this sort of rubbish. Okay, so now how do we answer the question of the physicist? So in order to distinguish between the derivative, which is capital D as opposed to these, which is the Lth output with respect to the kth input, we call them partial derivatives and we denote them by different symbol. This is del k. This is called del k of, or not del, yes, del k of YL. Sometimes you will also find del k of YL. Okay. So now you understand, just to describe the inputs and the outputs, we had to use linear algebra because the collection of inputs together form a vector in some suitable space. The collection of outputs form a vector in some other space. Usually our measurements usually yield real numbers. That's why we have taken these to be real numbers. But if you go far enough, you will see that it's just as easy to consider calculus in spaces of complex numbers. So you would have K complex inputs and L complex outputs. And that is perfectly fine, but it's quite difficult to deal with. There's a whole subject called several complex variables where they handle that. Okay. So for instance, just to make things clear or complicated, this is an aside. So I will mark this as an aside because you really need to understand the limits of what we are discussing. Suppose we say x squared plus y squared is equal to 0. And x and y are in the real numbers. What can you conclude about x and y? No, a better sentence. X and y are equal to 0 is not acceptable in logic. Yes, x is equal to 0 and y is equal to 0. And this follows from the fact that for every x in R, x squared is bigger than or equal to 0. So I'm adding two positive numbers and getting 0, therefore each of the numbers must be equal to 0. This actually, this was in exam 1B of linear algebra, I think. Something having to do with this. And then we dealt with indefinite inner products, in which case the length of something could be negative also. Okay. But suppose now I say that x, y are in C. Okay. So now you see if x and y are supposed to be in C, I could have 1 squared plus I squared is equal to 1 plus minus 1 is equal to 0. So this means that the set xy in R2 such that x squared plus y squared is equal to 0 is empty. But the set of xy in C2 such that x squared plus y squared is equal to 0 is not empty. Oh, 0, 0, sorry. Sorry, it's not empty. It's a singleton. Yeah. Yeah, that's called a singleton. Yeah, I meant to say singleton. It has exactly 1 in 0, 0, but is not a singleton. So I should say it differently, not equal to empty is fine. So the cardinality of the set of all xy in R2 such that x squared plus y squared is equal to 0 is equal to 1. But the cardinality of the set xy in R2, not R2, C2. C2 such that x squared plus y squared is equal to 0 is bigger than or equal to 1. In fact, it is infinite. Because why? Because 1i comma minus 1i, I found 2, but also 1 minus I minus 1 minus I. Are all in this set. So let's call this S. Right? So as soon as you go to complex number, many other things can happen. So the circle of 0 radius, the radius of that circle is 0, has points. Has points. Right? That's exactly what this is saying. So when you look at, I asked you a moment ago that can you really conclude that the space is of 2 dimensions? The space in which we are sitting is of 3 dimensions, or do we have to say that we have access only to the 3 dimensions? That is exemplified over here. So if you draw it on a piece of paper, circle of radius 0, you don't see all the points. But real numbers are embedded in complex numbers. And the moment we have complex numbers, then that point actually has more elements in it. Do you see? I will also tell you a story in the, does someone have access to Google? Can you check? Arash has a second job. Yeah. Can you check which year there was the shipwreck of the ship called Medusa, M-E-D-U-S-E actually in French, but M-E-D-U-S-A. Shipwreck of 1810. Okay, so 1810, in around 1808 or something like this, the students at the University of Paris went on strike, the engineering students, saying that the mathematicians were just teaching them rubbish because they were being forced to learn about imaginary numbers, which had been invented not very long before that. Invented, because it's a pure invention. All the numbers are inventions. Initially, numbers were used for bookkeeping, right? And what is a number? How would you define one? You see, this is not an easy question. This is a very difficult question because, no, but that's just a word. The collection of all 5 element sets is characterized by the fact that if you have a canonical 5 element set, let's say the 5 fingers on this hand, are in bijective correspondence to that. So that means fiveness is a property that is shared by all 5 element sets. So if you say, well, this is a 5 element set, it doesn't say what 5 is. Okay, so, and there's some tricky use of language over here also. If I say that I have red cars, it means that the collection of cars that are red and that are in my possession is not empty. And every car will have to be red. The predicate red applies to every car, right? But if I say I have 5 fingers, it doesn't mean that each finger has some property of 5ness. It's a predicate at the level of the power set. It's the set of fingers that is of cardinality 5. So these are tricky questions, actually. The numbers were defined only in the early 1900s. Before that, people just used them without perceiving the need to even define them. But computer science wouldn't exist without precise definitions of numbers. Anyway, the author of the book on variational calculus actually remarks that when the French students went on strike, they didn't realize that the shipwreck could have been prevented if they had the means to send a message to the lighthouses, for example, or to the shore. The sending of messages became possible with telegraph, right? And any kind of signal processing, almost as a requirement, now use complex numbers. So even the most useless of stuff in mathematics may have practical applications which people do not understand at the time. Okay, so that is one of the reasons for studying mathematics. No, because usually even the most esoteric area suddenly finds practical applications. The very famous mathematician Hardy wrote that he was very happy with the fact that he studies prime numbers which have no use at all. Well, if we live now, all sort of security coding require prime numbers. It doesn't mean that we can't find anything better, but we haven't yet. Okay, so now, okay, so fortunately, we will not be dealing with the complex numbers business. So now I have to teach you something very simple. So how do you compute a partial derivative? These are called partial derivatives. A partial derivative. So suppose I want to calculate del x of xy, or it can also be written del x of xy. It's very simple. You just pretend that y is a constant because y is independent of x, and you take a derivative of that function, considering it to be simply a function of x. So this is equal to y. Similarly, del y of xy should be equal to what? X. Okay, del x of sine, no, not sine. Del x of x squared plus y. No. Y is constant. So y should drop out. So this is equal to, no, x squared plus y by the sum rule. Del x of x squared is how much? Now it is one variable. So del x of x squared is, there's no y inside, so it should be the same as the ordinary derivative, which is 2x. And y does not depend on x. So del x of y is equal to 0. If, of course. So 2x. Everyone has fallen asleep with eyes open.
So I'm confused.
Yes.
So based
Go
off,
ahead.
as long as if there are two different pro numbers together,
Yes.
and we must treat them like we have to separate them to then be able to just go with the ordinary derivative route to solve the problem.
Yeah, in order to compute the derivative, not to solve a problem. So again, let me repeat. So if you have del x of some complicated thing, let's say x plus sine of yz. In this expression, anything other than x is to be regarded as a constant. And then you take the derivative as in ordinary. This step is not required. So this becomes 1 plus 0 is equal to 1. Okay? And all the things about chain rule, etc., all of them are valid. So you just have to make sure that you remember that anything other than the x is a constant. Okay? And this will require some practice. Okay? Okay, and what does this mean geometrically? Geometrically, what does the ordinary derivative mean geometrically? Oh, actually, just the light went out twice. That means it must be at least 6:30. What is the time? Yeah. Okay. So we are in the second half, and we can also use Maxim as a measurement device. Except that I can't distinguish someone who is awake with eyes open from someone who is asleep with eyes open. So I don't know how to use Maxim as a, you will have to declare, I am asleep. Then I will know that 1 hour is over.
I was asleep a minute ago.
Okay. That's good enough. Okay, we can take a break if you want.
No, I just need sometimes I don't realize, but I need a wake up call.
Okay. The wake up call is the second time the lights go out. Although that is more likely to put you to sleep than anything else. Do you want a break? We can take a break. So we can, everyone's fine. What about the people? What about the people? Jesus, you have not submitted the 6 first pages. And therefore you did not get the 7 points which were free. So you go back home after the class ends, you immediately go and submit all the 6 pages. Did you hear me?
Yeah, I heard you.
Okay. Okay, so where was I? Yeah, we were doing the derivatives. Okay, so this,
We were starting to talk about how it would look in the geometry.
oh yes, in the geometric sense, yes. What is the geometric problem that we tried to address in differential calculus? The geometric problem that we try to address is the following. If you have some sort of a squiggly thingy, you want to find out the straight line that fits it the best at a certain point. Why? That approximates, that fits it the best.
Isn't
Fits the
isn't the derivative the rate of change at a particular point?
It is the rate of change at a particular point, but that is the physicist's view. This is the geometric view. So the rate of change at a particular point is actually the slope of the curve. Okay, so the physicist wants to know if you wiggle the input, how does the output change? And he wants to know how this occurs at particular values. Okay. The trader who is trading stocks wants to know what the value of the stock would be at after some time. In this instance, this is time, and this is the value. In this case, of course, it is not known how it is going to change in the future. So the sort of crudest approximation would be to say that it doesn't change. This does not please the trader because the trader wants to sell at a higher price. Therefore, a better thing to do is to take the tangent to the graph at the point and pretend that it will be the rate of the increase will be flat. In this case, he will get this value, which is much beyond the actual number. Okay, so this is the economic motive, but these are not the only two motives. The physicist motive, which I didn't write down over here, is to understand the real nature of the macroscopic variables that we can measure and that characterize a system. So it is now an extraordinary feat of physics that we know that if you have an ideal gas in a container, to describe it, we need three unknowns: pressure, volume, and temperature. And there's a law that tells you its behavior, and that is PV over T is equal to constant. Okay, so that means the system is characterized, it moves in such a way that PV over T remains constant. We can think of the gas as a point in three-dimensional space, PVT, okay, and PV over T is equal to constant, describes some sort of a twofold, one equation that describes a twofold, on which the state of the gas must lie. Now, what does PV is equal to PV over T is equal to constant look like? What does PV is equal to T, PV over T is equal to constant look like? Those, I want you to imagine the set PVT in R3 such that PV over T is equal to constant. Let's say, well, constant, K. K constant.
So
Okay.
a linear
Moral of the
line?
story, before I proceed, have you all either begged, borrowed, or stolen a copy of Mathematical Handbook by Shams? You really have to do that because it has all the pictures in it which you must learn, because otherwise you will not understand what is going on. Yeah, Rivera.
I was trying to answer your question
Go
before,
ahead.
and I mean, would it just be a linear line?
No. Well, first of all, what is a linear line? That doesn't make any sense.
Well, how am I trying to say this? Well, it's a constant, right? So, I mean, it's not going to be,
No.
it's a
PV
flat
over T.
of some type.
No, it is not a flat because the equation is not linear. It's P times V over T is equal to constant. If the equation is linear in the unknowns, then it would be a flat, but it is not a flat. It is a twofold, a real twofold. No, why should K be P? K is some constant like 2 or 550 million. Or -1. -1 is actually not possible over here because P, V, and T are all positive numbers. So for the P is the pressure, V is the volume, T is the temperature. But if I consider from the point of view of mathematics that pressure volume cannot be negative is not of any consequence. We should consider this one, xy over z is equal to constant. This is a twofold in R3. Yeah, because there's one equation, yes. Okay, so what does xy in R2 such that xy is equal to constant look like?
Oh, that's a straight line.
No, x times y. This is very bad. Okay, you go home and first find out what these shapes are. No, you are going to look it up. That is, of course, of no use whatsoever. That means you are not only are you opting to become a cabbage, you are becoming a cabbage. So this is absolutely unacceptable. It is a name. This you should know from basic pre-calculus. It is a rectangular hyperbola which I've talked about today. So whatever happened? xy is equal to constant looks like this. Constant bigger than 0. If it is less than 0, it would be something like this. And if you have different constants, for different constants, you would get different branches, basically. And the two straight lines is the extreme case. xy is equal to 0. If xy is equal to 0, either x is equal to 0 or y is equal to 0. So you get just Broad Street and Market Street. Okay? No. They all look like, all are rectangular hyperbolas. For different constants, they can't intersect. Okay? So now, so that means if I take xy over z is equal to constant and set z is equal to constant, that means, look at me. So I have, let's see if I'm visible. So x and y axis, z axis. So this xy over z is equal to constant is some twofold over here. If I slice it by a plane which is z is equal to constant, that means something which is parallel, a plane which is parallel to the xy plane. In that case, I will see these graphs. So what does the whole thing look like? So I've only told you about one section. Okay. What happens if I hold, rather than z is equal to constant, I will hold y is equal to constant. If I hold y is equal to constant, then you get x over z is equal to constant. X over z is equal to constant, if I call the constant k, is x is equal to kz. X is equal to kz is a linear equation. That means if I hold y is equal to constant, that means I am chopping it by something that is parallel, y is equal to constant is parallel to the xz plane. If I chop it by a plane parallel to the xz plane, in that case, I get a straight line. Similarly, if you hold x is equal to constant, you get y is equal to kz, which is also a straight line. If you chop it by a plane parallel to the yz plane, you also get a straight line. So if you chop it this way, you are getting these curves. If you chop it this way, you are getting straight lines through the origin. And if you chop it this way, you are also getting a straight line. So what does the whole thing look like? Now, you should consider this question very carefully. The reason is if you have some sort of a tumor somewhere in your body, okay, then the doctor, before they make an incision, need to locate it, right? So they take many sort of sections, they make images of many sections of your body, including the tumor. But from these two-dimensional pictures, they have to put together a three-dimensional object. And do you understand that that is quite difficult, actually? Those of you who want to go into signal processing or image processing will never be out of a job, because it's an area that needs almost infinite improvement. So, and computer science and multivariate calculus are very strongly needed. The last time I went to India, which was in December, they didn't look at my boarding pass. They asked me to stare at a camera, and they did face recognition. Now, but the face recognition that they do uses this, but in a very crude manner, because they have a statistical measure of what it means for the image that they capture and the image that they have saved to be correlated. Okay. My computer, on the other hand, cannot recognize my fingerprint. So the data I put in wasn't enough for there to be a clear recognition. Now, this is an area which will develop enormously. Okay. So this is something that you should think of. So those who are in computer science should take 271 if they wish to go into this field. Pattern recognition is becoming more and more and more useful because new technologies are being built. Yeah. So that is why 271 is important. Do you understand what I'm saying? Okay, so those, I write to the computer science people that they should take these classes, but very few listen. Okay, so again, I will repeat that the best preparation for any engineering degree is a very strong background in physics and in mathematics. And if you can, biology also, because there's a lot of stuff in biology that are happening that people don't really, I mean, people look at from a very crude point of view. Okay, so for instance, it's just people are just beginning to look at molecular algorithms. That means you have an algorithm, but how can you realize it using molecular dynamics? And that is happening within us all the time. Okay, so these are the things that you need to very clearly understand. Okay, this problem I shall not solve at the moment. So I want you to, without looking at the internet, because in that case you prevent your brain from developing, which is a harmful activity. Try to imagine what the surface would look like. There used to be a subject called descriptive geometry before, and architects and artists used to take it, where they would give you a certain number of sections of some three-dimensional object and ask you to draw the object. And it is not easy at all, which reminds me that the three-cylinder problem, which I told you about, I will write up and send to you. Okay. You have to find the vertices, find the edges, find the, and then find the coordinates of the vertices, the parameterizations of the edges and the parameterization of the faces. Each edge is bounded by two endpoints, and which are the vertices. Each face is bounded by 4 edges. And then you have to find the area of each, the length of each edge, the area of each face, and the volume of the whole thing. Clear? Okay, and I saw, as I told you, a lot of rubbish about the thing, including some trivial business, which I have published as papers, but I will send you all of those. Okay. I said that I will not answer that question. I told you.
In each of the 4 quadrants.
There are 8 quadrants. Well, there are options in a three-dimensional space.
Yeah, you have this. You see, this is the first octave. So plus, 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 minus, that would have to be extended to 3 dimensions of plus, 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 minus. Okay, there are 8 of them, 2 to the 3. So in each, first of all, does it come in 8 pieces or can it cross the axis? Why?
It won't cross the z-axis.
Why?
Because z can't be 0. That's
Z meaning, okay, Z can't be 0. Yes, it's in the denominator.
the same thing with x and y. Well, cross those.
Actually, rather than writing Z in the denominator, let's say XY is equal to KZ.
So we're assuming the constant of only z, right?
No, we are not assuming that at all. Just in the case of the hyperbola, I said that if the constant is equal to 0, they are just the 2 axes.
Okay, so only if the constant equals 0, x and y.
No, let's remove the Z from the denominator and say that XY is equal to KZ. So you have to find this set of all x, the shape of this set in R3 such that XY is equal to KZ, where K is some real number. I mean, I really should write it this way, and K is a real number. So it is, if Z is equal to constant, let's write this. So if from Z is equal to A in R, I get the set XY A in R3 such that XY is equal to KA, right? Which means this A is equal to constant means that everywhere on the set, A is a constant. So we might as well consider this XY in R2 such that XY is equal to K. Okay. Similarly, if Y is equal to B in R, what does the equation become? It becomes XY, XBZ in R3 such that XB is equal to KZ. This is a linear equation, so that's going to be a straight line. If X is equal to, oh, I should not have written Z is equal to A, I should have written Z is equal to C to be consistent. C, A, C, C, K, another one, C is equal to KC, KZ, and X is equal to A in R, A, Y, Z is equal to in R3 such that AY is equal to KZ. So it's this, rather than looking at the 3-dimensional object, we might as well look at the 2-dimensional object, which is a cross section. XB is equal to KZ because B is constant. And here I should look at YZ in R3 such that AY is equal to KZ, which is also a straight line because it's a linear equation through the origin. It's a straight line through the origin. That is very important. So now, let's take something where we are doing the opposite. Suppose I have a cup, as he was talking about. So this is an example. Suppose I have an upside down cup. That looks like this. Okay. If I take cross sections parallel to the x-axis, what do I get? Cross sections parallel to the xy plane. Yeah, I will get circles, right? So I would get this. These are the cross sections parallel to the. Okay, if I take cross sections parallel to the XZ plane, so these are Z sections. Z sections means sections parallel to the YXY plane. Sections parallel to XY plane. Maybe I shouldn't call them Z sections, but okay. XY section. Okay, if I slice it this way, I'm going to get things like this, right? Arches, as I said. So the XZ section will look like this. The arches will be of different sizes, of course, right? Because the cup is finite, so they will increase in size. So what happens if I take the YZ section along the XZ section along the XY plane, that for that the constant is 0. So if this is X and Z, it will be this way, right? Okay, that's for 0. Then there will be other smaller pieces, and at some point it will stop. Okay, and those can't cross, right? So this, etc. And the same thing will happen with the YZ cross sections. Okay, but if I gave you these cross sections, you have to imagine that it is this shape. Do you understand what I'm saying? Yeah, and that is the process that you need to learn. And it's not easy. And if you look at the internet, you approach a cabbage at high speed, which is not desirable. Do you understand? That's not a desirable goal for a human being. Then I will take you and put you in a grocery shop on one of the shelves. So, and then they will spray you with water every morning before you are sold. The next stage will be sauerkraut. You will be fermented in vinegar. Pickling, yes. Okay, so this is not easy. What I so yeah, this you have to. I mean, I can just tell you roughly what one needs to do, but you have to practice on your own. Okay, so I can't get inside your head and make the images appear. So your job is to find out what does PV over T look like. Okay, so 2 of the sections are straight lines, 1 of the section is a hyperbola. But what does the whole thing look like? Okay, so it should be about what, 7, quarter past 7, 20 past 7? It's about 7. No, it can't be. Oh no, it has to be 7. It went out off 3 times. Yeah, it's 7. Okay. Every 30 minutes, yes. Yeah. So now, this has to do with being able to imagine the things. Okay. But what is the problem that we are trying to solve? So the problem was to find the tangent or the best fit curve, right? But what happens if I have something like this? A 3-dimensional object. So I would have to fit a tangent plane. But what happens if you have a k-fold in p space? Then you would have to fit a k flat to it locally. A k. No. A k-fold in p space means you have something defined by k parameters. And then you have to fit a k flat at a point. You have to find the best fit k flat. So now you will see what it means to get a flat approximation to something. Because the equation of a line is y is equal to, the way it is taught here in the US, y is equal to mx plus b. Right? So, but now it will become y1 up to yq is equal to some matrix M, x1, x2, xp. Oh, q looks like a y. Q plus B1 up to BP. And yeah, the slope is, M is in matrices of size. So it must take how many rows and how many columns? Yes.
Columns would be for the how many X's there are, right?
You have to multiply a matrix, right? So
yeah, and then
let's say 1, 2, 3, 4, 5, 6 times A, B, C. So the number of columns is equal to the number of entries in this vector. So the number of columns should be the entries in the vector. There are p entries in the vector. So number of columns should be p. The number of rows should be
q.
So note that the slope in baby calculus is a number, but the slope is actually a linear map from RQ to RP. Okay, and the first exam will, the 1B will be concerned with finding flat approximations to functions and the tangent flats to folds defined by equations. Is this clear? Okay, now the things are not easy anymore because it requires you to develop your faculties. Yeah, so and now I want to know, I mean, I am talking in a certain way, how much is being communicated? So you will have to give me some sort of a subjective measure. That is, do you understand the nature of the material and why it is not entirely trivial? Okay, so being able to get good grades on the problem, on the exams, does not mean that you have really mastered or developed the ability to imagine the objects. Okay, the exams are set up in such a way that if you work with sufficient discipline, you should get a good grade. But it's just, that's where the problem starts. Okay, it's really not easy. Yeah. Okay. So I will pause. I mean, in principle, I should pause every half an hour to ask you if you have questions. But so, any questions?
I have such a small understanding that I don't have questions.
That's okay. You can ask me later. You will.
Get why B is not a constant.
B is a constant. It's a constant with p entries. You wouldn't, on the left side, if you have a list of q things, sorry, they were not p entries, it has to be q. I made a mistake. Just a second. This has to be Q. This is multiplied by matrix, so this is P entries. These two have to be Q, and when you multiply, it will be Q entries. What do you not understand? Why B is a constant?
Why we have to be instead?
How can you add something which is 2 by 3? Again, type checking is becoming a problem. So it will look like this. Y1, Y2 is equal to, let's say, ABC, PQR, X1, X2, X3, plus B1, B2. Something like this. If this has 2 entries, this also has to have 2 entries. Otherwise, you will not be able to put them to be, they're not of the same type. This is M. This is B. This is X. This is Y. This is the description of a.
Okay,
Okay, so tell me,
I got it.
this equation describes what in how many dimensional space? So fill in the blank. This equation describes, wait, a blank flat in R to what power? This is taking too long.
R2.
No, it is not R2 at all. Okay, Y1, Y2. It is in R to what power? No, Y1, Y2, 2. And X1, X2, X3 in R3. Okay, so the set of all, wait, X1, X2, X3, comma, Y1, Y2 in R to what power? No. No. There, how many entries are there? No. 5. So it's R3 plus 2. Such that what happens? Such that this is true. So Y1 is equal to how much? Y1 is equal to AX1 plus BX2 plus is equal to AX1 plus BX2 plus CX3 plus B1. And Y2 is equal to PX1 plus QX2 plus RX3 plus B2. How many equations? 2. 2 equations in 3 dimension, in 5 dimensional space. So that's what flat? 3 flat in R5. You have all forgotten everything. So you really need to pay very close attention to that. You can't get the sizes wrong. This says the same thing as this, the set, but you can multiply in your head and see how many equations there are. Okay. Here I made if I said this, what shall we call the coordinates? Let's call them Z1, Z2, Z3, Z4, Z5 in R5, such that Z2 is equal to ax1 plus bx2. Sorry. So these are just 5 numbers, and suppose I say that z1 minus z2 plus z3 plus 3 is equal to 0, and z5 minus z2 plus z3 plus 4 is equal to 0. And so this is 5-dimensional space, right? And this is a 3-dimensional object. So these axes that I'm drawing are made up by me. If I just see, let's say, this surface, this surface. This is a 2-flat in 3 space. But am I going to take that as my origin and these as the axis, or that corner as the origin and those as mine? The description will change. So if you have such a flat in space, its description will require a choice of coordinates, but the thing itself is independent of that. It's like Arash's height. Whether it is 72 centimeters or, 78 centimeters or 172 centimeters, depends on where you measure from. If I say I'm 120 years old, that's an absolutely true statement. I didn't specify the origin. I could also say that I'm minus 50 years old, meaning that I'm counting from my death, which I don't know. Which means I'm making a statement that I shall die in 50 years from now. So it is very, very, very important to understand that measures are not absolute. They are with respect to a certain choice of coordinate systems and units. So he said he gave me 2 values, 5 feet 8 and 172 centimeters. So these are with respect to 2 different systems of units. It is very important to know this, otherwise you might have the same sort of disaster that happened at NASA. The Europeans calculated in the metric system, the Americans calculated at the with the old English system, and the thing blew up, and all of us lost money because it's the tax monies that were used. So these are very, very important ideas which you must always keep clear in your mind. So again, I will repeat, the most difficult aspect of this business is to set up some sort of a correspondence within your head between shapes and equations that describe the shapes. First step is to get the Shom's Outlines Mathematical Handbook and look at those shapes. If you don't want to buy it, you must spend time to download from some internet site all those things. I sent you videos for the Tesseract last time by Eugene. What was the last name? I keep on saying some wrong thing. Kurtianowski or something like this. Okay, so you have to look at the Tesseract and see if it helps you visualize higher dimensional objects. Now there are 2 people falling asleep rather than 1. So I think we should call it a day. Are the people, the virtual people, asleep or awake?
I'm awake.
I'm here, but there's stuff happening now.
Okay. Now, yeah, as far as, let's see, Riviera is concerned, the I have to point the following thing out. If you look at the score of some piece, in that case, you have the geometric description, but from that, you have to produce an auditory description, or at least be able to imagine the auditory description.
Yeah.
And that requires a similar type of development of the brain.
Yeah, I'm still trying to figure out how to make it apply to math. I'm very good at the sight singing, but when it comes to imagining, like
Yeah,
first
but
when you said,
sightseeing means that you can read it locally. What I am asking you to do is to get a global view.
that's how you do it though. It like what you say is like, that's basically how I do it, which then causes me the ability to be able to sight sing it. I am able to think of it in my head. And because I'm able to think of it in my head, I'm able to like produce the sound.
I understand. But now suppose I say, sing it 3 half tones higher. Then if you don't know the global thing, it would be difficult to produce instantly. But if you know the tune globally, then it is easier to translate.
Or you could have perfect pitch.
But the pitches are completely arbitrary. I mean, the concert C is different in different countries. Actually, if you look at the history, even Boston and New York did not agree in earlier times.
In earlier standards of tuning, there was not an agreed upon like pitch. And that's why lots of organs around like the world are
Yes.
technically tuned to different like frequencies.
Yes, that is exactly the point, but that is the natural state of affairs. To impose an arbitrary coordinate system is a disadvantage. During a particular concert, you must decide on some particular values, but there's no absolute here. But you have to choose the origin, and you also have to choose the anyway. So the reason for bringing this up is in the case of Riviera, 2 different sense organs, the auditory organ and the visual are being related. Now, if the score is replaced by a sequence of numbers, one could train oneself to be able to sing those frequencies without looking at the form. The form helps us because we can see if I'm going to sing higher or lower, etc. That gives you a rough local description of what is going on. So over here, something similar is going on. You have visual description. You have a algebraic description. From that, you have to produce a visual description. Okay, so 2 sense organs are to be related, and this is not at all easy. Is the problem clear to everyone? Okay, so let me give you another kind of exercise to develop your brain, which unfortunately, yes, I suppose, can one see no, one can't see the, how on earth am I going to show the surface of the, which camera? On the iPad? No video, okay. That's probably best because, okay. So now do this. All of you are in front of a table, right? Okay. With the right hand, go this way along the surface. No. You have to touch the surface. Otherwise, the experiment won't work. So you have to move. Okay. And with the left hand, you go up and down. And then change. Yes. So this, I'm telling you to do this because this would essentially allow you better control on the 2 sides of your brain, which act somewhat independently. And that is a preliminary towards getting that sort of ability. Okay, but it requires practice. You see, it's hard to do this. Or if I ask you to rotate it in one sense and rotate the other one in the opposite sense. Okay. Yeah. Yeah.
They work independently. For some reason they want to take the same path.
Yes, there. So the programming of the brain is such that, yeah. So in the next class, I will see if you really know where your noses are and where your ears are, as preliminaries to being able to imagine these things properly. Okay. So, okay. Now I will stop. Okay, the virtual people, any questions from you? I can see Byron, 2 instances of Byron. One,
Yes. Yeah. There's
Max,
2 of me.
and there's nothing at all of the rest.
Sometimes that happens based on your setting for Zoom.
Yeah, because I mean, I suppose I can't scroll down. Oh yes, now I see 4 more people.
There should be a
Oh,
button in the
I-
top right corner that says view, and then
Yeah.
you should be able to change it. Gallery might be the one you're looking for, where you can like then.
no, gallery would view options. Exit full screen. Yes. View options gallery. Where's gallery? Gallery has disappeared.
Side by side gallery.
No, except for the fact that side-by-side speaker, side-by-side gallery, yes. Yeah. But now if I go to the full screen, yeah, it doesn't put all the, yes, now I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is that all in the class or is there more? Okay, 12 or 13? No, 11, there are 11 people. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Caesar has disappeared. Caesar is here?
Yes, I'm
Oh,
here.
yes, Caesar is here. Yes, 1, 2, yes. Well, my screen for some reason is accommodating only these many. Okay, so now I will go. Then I will stop it. Do I have to, I end the meeting and then stop recording or the other way around?
Other way around.